Okay, so Jan Hall is going to be the moderator for the last session on research opportunities. So I think we might need a second just to move the slides around here.
Sure. But I could probably sort of give a few general comments to start with, just as you're getting some of the specifics up. So clearly today we've had, yesterday we've had an incredibly rich discussion. And I think that every single person who has spoken around the table has brought up things that we don't know enough about. And so I think that we're going to have a lot of gaps that we want to be able to think about. One of the things that we've been charged with is actually looking at, what are some of the short-term things? What are some of the things can be handled in the short term that will help, that will enable studies in the future do a better job? So I think that's part of what this discussion is about. And I think that we've begun to hear a couple of suggestions that have intrigued me. And I would say the first thing relates really to Mariana's very important concepts about sort of measuring the exposure and the sort of chip technologies and things like that that are beginning to come on board, and getting some sort of a sense of what the pace of those kinds of things will be, I think is very important. So love to hear more comment about that. And the other things that we've been talking a lot about are what about, the biomarkers relating to outcome. And again, we've talked about some of those things here. We've talked about epigenetic markers that may in fact be important and that we may be able to develop to give us a marker of exposure. We've talked, there's been some discussion that immunology might help to bring together some of the disease processes that we've talked about, and one of the suggestions was looking at CRP as a potential biomarker that might kind of help to bring some of those together. I think there's other things that may relate to markers of oxidative damage. Thyroid function is something that has been used in the past to look at things as variable as overtraining. And is that something that might be important? Somebody brought up the issue of looking at white blood cell counts, and is that something that might also be a biomarker for certain things? So just sort of thinking about these two areas of research in exposures and what are the questions we want to know about that, I think would be really important. And I wonder maybe if we should start with that question and then move on to the potential biomarker question and any other questions that people think might be that might not be covered by these two areas that we think might be important. So if we could talk a little bit about the exposure end of things first.
What's that fit into which of your two? You had two bullets here.
Yep.
I wasn't quite sure where that fits in.
I'm just making this broad right now.
Okay.
Because I think this is really,
measuring.
yeah. So, so I think the first one really is what are the short-term or experimental studies in animals or cells or on biomarkers. So maybe we should start about at the other end. But I think that you can't talk about an outcome unless you talk about standardizing an exposure. So, I mean, if we're talking about light, if we're talking about circadian disruption, if we're talking about whatever, what are the things that we need to standardize the exposure? And, yeah.
Go ahead.
I can speak on the basic science animal side.
Yeah.
I think for these basic science studies, I think it's really, really critical that animal facilities are constructed with light-tight rooms for the dark phase. I think this is really critical, because then otherwise light contamination introduces a confounder that's going to screw up any kind of exposure that you use. And so for basic science work
Yes.
that eventually clinical work may be informed by, I think that's a real important issue.
Unless at some point there becomes a consensus in the community that we never have total darkness, and therefore what we need is some sort of standard low light. I mean, just as another way of thinking about that.
Well, yeah, but
Yes.
we have to know what total darkness
Exactly,
does,
yes.
and then we can always
Yes.
work from
Exactly.
there. From
Yeah.
there, yeah.
Yeah, yeah. Mariana?
Just to add on to that, I mean, the way these animal rooms are housed in my university and how many racks are crammed in, the light intensity varies probably 100, the bright light intensity probably varies 100-fold as a function of where the cage is.
And I think it's even fluorescent lighting that we have typically in animal labs. It doesn't look very bright to us, but there's like exposing those poor babies to multiple suns. So what is it doing to it? I think this is a long term. I don't think we're going to change the practice that easily with that, but I think it's something we have to start thinking about. That's one thing. I think the other thing for measuring exposures, it's what Dr. Brainerd mentioned in laboratory studies is that people start basically reporting a little bit better what they're doing in terms of lights, spectral power distribution, light levels, things that everybody can look at it and perhaps replicate. And I think the third one is the field studies. And, we try to address that by developing that device. We don't commercialize it. We get every week somebody asking us if we sell these things, and we don't. We're a university. We're not interested in selling things. We're interested in, having these things, somebody perhaps do it. But the key about that is just not putting an RGB sensor together. It's really the calibration part, and that's really where having some expertise and understanding and perhaps developing some specifications for that would be useful. And then you have the issues that I think Dr. Byrne brought it up. Yes, it is retinal light exposures. We unfortunately cannot put a sensor in the retina. And even if we measure that, you have the processing that occurs in the retina and it gets to the brain. So we're all going to have to get to a point where we say, okay, we can't do it as well as we want to do it, but what is it that we're comfortable with doing? I mean, we started with the light at the eye, which is where we want to measure. Compliance is really hard. Having nurses wear these things for 7 days, 24 hours a week is really hard. So you're moving more for pendants and pins, but then a lot of people wear on the wrist. Wrist is probably the worst case scenario because you cover it up a lot and so on. So those are things that we need to, it's going to be a compromise, but I think it's worth talking and discussing it. So.
Yeah.
Mariana, are you saying that we need a socially acceptable sensor that is small, that can be placed under the eye, that can record different spectra of light, of exposures on a time basis with transmission?
Do you have that?
I think it can be developed. I think if somebody wanted to go with an SBIR, I think there are people out there who could deliver.
And then you got to put the sensors that Fred mentioned under the skin so you can measure the outcomes as well. So there you go, you're all set.
Well, I mean, that.
Yeah, no, I think we're
the
closer.
I will tell you, I think the technology
With the
exists.
nanotechnology and so on, I think we're closer, but
Because when I talk to my engineers, they say, "Oh, really? That's not a difficult thing," because there's a whole lot of technology that's really miniaturized right now, and I think we need to start talking with our biomedical engineer brothers and sisters of what we need to get real-time data in a socially acceptable wearable device.
And just to finish that thought, I'm sorry, I agree that collecting the data is important, but just as important is interpreting that data. So there's a whole other level of doing the interpretation as well.
That's fine. We just have to get it done with a nice software program that goes with the hardware.
So I think there's an important knowledge gap about longitudinal development in both shift work and light at night, and how that influences the exposure and how age interacts with the exposure. So I think this is probably very relevant, nearly more so for the light at night, where we got tablets, we got kids on their tablets at all, and we simply don't know. So I think it's probably also very relevant for the question around biomarkers. So what might be a biomarker for someone in the first year of shift work may be different than when they're 5 or 10 years in. It may be different if you start shift work when you're 18 to when you're 30. So I think there's a real need, not going for the full Framingham study type thing, but the fact that it's in and to accept it may be a very dynamic and adaptive process that's happening. And that age, we know age profoundly influences circadian rhythms. It's such a major confound. So age in itself, but also if you're older, you have the possibility of much longer exposure to whatever the exposure ends up being.
So basically, I think the point you're making is that no matter how well you quantitate the exposure, you basically have to take into account the kind of biologic substrate in terms of age, but also the duration of exposure and potentially the intensity of exposure. Yeah.
And that is true, but of course not different than for any other chemical that we would be interested in, which of course has an age-dependent effect as well. So in that sense, I don't think this is necessarily, it's important, but it's not necessarily completely different. I think just to go back to the exposures, and I fully concur with the fact that with the new sensor technologies and the ways that we can actually measure these things now and in the future, that at this time what you're doing and what we are doing is trying to get a better idea of what these exposures are. And that's going to be very important. That cannot be scaled up yet to the large epidemiological studies that we have because it's too much of a burden for the participants. B, the sensors are still quite expensive, and even to get them to 60,000 nurses would be prohibitive at this time. However, in the short term, these studies can be used to calibrate basically our questionnaires, or at least to know how much measurement error we actually have when we actually look at a particular question. And at this time, I have no idea. I don't know what my measurement error actually is. And so that's going to be in the short term very important. The long term is basically when we get these sensors and there actually is going to be a market for these sensors, then actually it may well be that these things become much smaller and cheaper, which we of course now have with Fitbits and Jawbones and all these kind of things. So in that sense, there may actually be opportunities towards a future where we can actually get more objective data. I do think that's very important. I just want to say that light is not the only thing, so there is all the other things that we also have to think of how we capture diet and all the other things.
Right. So I think, the low-hanging fruit in this, maybe it's in the animal models since we heard so much about the differences, but I still think it's useful is to try to get a sense of the balance between, what's the dose response, I guess. So what's the balance between intensity and spectrum and those kinds of issues, because, not every photon's equivalent in terms of having an effect. And so, if you're talking in lux, as Mariana can correct me on this, but 5 lux of blue light's different from 5 lux of red light, and so yeah. So for the circadian system, so I mean, I think we need some sort of dose response. So when you get beyond the research opportunity, the PR opportunities of people, I'm sure everybody here gets asked, well, how much light at night should I receive, right? And we don't have an answer. I think it's just like, anything else that's bad for you, you should limit your exposure to light at night. I think that's the best message we can give at this point.
So just in terms of the specific question that Wendy and Ruth have asked, are there any short-term things that could be done to maybe at NTP or maybe kind of through some contract mechanism or some sort of thing like that? I think that one of the things that you're saying is that actually may be one of those things that's really important, because many times, this is one of those things that may not be at the heart of your scientific program, but yet you still need the information, and that information is going to be important for a lot of people. So I think that's actually a very interesting, a really interesting point to know.
I guess two quick things. Everybody says quick and then goes on and on. I love it. It's already started in the very controlled laboratory settings with human beings. They've got a lot of press. The first that I was aware of, ordinary room light, in Journal of Clinical Endocrinology. Then the computer tablets was all over the news, and then the e-readers. And the outcome was for these were dim light melatonin onset. So you have this light in the evening. How does it affect DLMO? And one of them actually scored sleep. So this has been started by very serious labs, very carefully done, in very carefully lighted conditions by people who understand the dose response for the circadian system very, very well. That could be expanded and should be expanded to have the same kind of laboratory setting for these things we've been talking about. Maybe the methylation and other genetic or CRP, I like C-reactive protein. I've known C-reactive protein for a very long time. 30 years ago, people said it's too general. You can't get a grant to study that. Now everybody loves CRP, and I think that's a very good thing. The other very quick thing is, for the epidemiologic studies of chronic disease, there are two major things. There's all kind of design issues, but there are two major things which we're very concerned with. One is misclassification of exposure. This is assuming you can ascertain outcome well. Misclassification of exposure and confounding. Now, the poorer the exposure, you can never have a perfect exposure, you can never have a perfect measure of the exposure of interest. Retinal photons, can't even do that. So we have to come up with surrogates. The surrogates we've come up with have been things like the DMSP satellite, occupation in cohort studies, sleep duration by report, bedroom light level, and misclassification will tend to reduce the ability of those studied to see a true effect, see an effect if there truly is one. The fact that we're seeing these associations is provocative. So then it might be it's confounding. We do the best we can to try to adjust for confounders. But among most epidemiologists, most of us, I think, we have some epidemiologists, I'm much more concerned about misclassification actually in the long run than confounding, although I take confounding very seriously. But you said it very well, Roel. We simply can't use these meters right now for the chronic disease thing. Despite the poor exposure measurement, we're still seeing relationships.
So then maybe just to finish off on this piece of exposure, is there anything in terms of short-term studies that would help narrow that gap between the things that you know how to measure and the things that we've seen measures of, and something that's on a more personal level that might be a potential short-term experimental model that can be used to actually answer questions for the field?
If you want to know, I'd love to repeat your studies with a biologically meaningful light for your animals. I think that would be, and do a dose response. Well, I mean, what would be equivalent to what room lighting is for humans, and then we do a dose response. I think that would be, I mean, you have all the outcomes, you have and we just do the dose response and just get what are these light levels and how they're equivalent to. We have a lot of data on people's homes, what they're exposed to, because we've collected a lot of dosimeter data for different populations. So I think it would be great to do something like that. It doesn't have to be with our data or your data, but something like where you can, and I think that's one first step of doing that translation from animals to humans and trying to see that relationship. I think it would reinforce the animal models a lot.
And then to speak a little bit to the discussions at the beginning about sort of the animal facility rooms. I mean, one of the things that has been done in different areas has been to have specific journals put out kind of recommendations for standardizations for studies so that people kind of know what they're aiming for in terms of the quality of work that's being done. And I think in some ways that's the best way of really spreading that kind of word. So I think maybe we should, oops, I'm sorry. One other comment, I'm sorry.
I have two comments. Alec Davidson. I have two comments. One related to the classification or characterization of exposure. in animal work. And I'll say guilty as charged, and I think a lot of the people in the field, we don't do a good job of really characterizing intensity, wavelength, composition of the light stimuli, even though that's our major independent variable. So it's something I've been thinking a lot about, getting right. Another topic that I'm guilty as charged, and I think applies to the whole field, and it's a gap, it's an opportunity. And that is that our animal models of disease in this realm, circadian disruption, shift work, are more often than not, I'd say almost always, based on experimentally induced disease. This is not spontaneous disease as occurs in the human epidemiology. And so we set our disease incidence at 100% just because it's convenient and we want nice control, and we look at severity as an outcome. But really incidence, I think, is something we need to be more focused on. So we need to develop or find animal models of spontaneous disease and be a little more patient with our experiments potentially to have them be more relevant to human health.
Thank you. Really good things to include in our thought structure about this. So I think that I guess the next two topics we really have is the end of the first question and the second question, and they both have to do with biomarkers. And I know we've started to talk about that a lot, but I'd love to get a little bit more of a rich discussion going. So we want to talk about biomarkers of outcomes, and we want to talk about biomarkers of circadian effects. And the question is, can they be separated? Should we be talking about them at once? How exactly should we be thinking about those? So I don't mind if we talk about them together. I just think those were the two things that are still kind of on the table as questions.
I think there's a couple areas where there's overlap in potential biomarkers besides the circadian markers people have been talking about, and whether those are in the fibroblasts or white blood cells. But I think one thing I've heard that's common, and certainly common among the animal research, is that exposure to light at night, whether it's through shift work or experimental model, tends to cause inflammation in the periphery and tends to cause neuroinflammation in the brain. And I think whatever the pathway, the signaling pathway is to dysregulated clock gene expression, whether it's amplitude or shifting the peak or whatever, and how that leads to inflammation, I think will be important to know in terms of this circadian disruption, cancer or non-cancer disease relations, because I suspect that probably not causative per se, but certainly facilitatory for tumors to take place or for strokes to get worse or what have you. So I think something on the mechanisms at that level of inflammatory, and maybe it is CRP, but I think that's going to be an important biomarker just to get to that, because it seems like a common mechanism around.
Yeah, I want to make the point that we've mentioned it a couple times, but I don't think that we are using the power of genetics. The reason the mouse is the model organism now for mammals, for a lot of reasons, is the genetics. And when you have to think about genetics, we can not only do conditional knockouts, we can do tissue-specific knockouts for genes. But then we also can look at different strains. There's now, I think it's 40 strains of mice that have been totally sequenced. And those mice have different phenotypes. So if we phase shift the animals, will some animals phase shift faster than others? Or we were talking about chronotype, and so how do humans that have different chronotypes, we have the capability of going and looking at some strains of mice that have different chronotypes. By that I mean there are some mice who are early risers and some mice that are late risers. They're owls and larks, and that's genetically driven. I mean, the strain of mouse they're all the same. So they'll be maybe, let's say, really active, I'll call it, in their early active phase, and then toward the evening, man, they're out. And others are a little bit light active in the beginning, and then toward the evening, they're really active. So I think there's a lot of genetic approaches which have been used in lots of areas now. But we, for example, we really don't look at, we've done a few studies, but very limited, for how would different strains of mice say this strain of mice is susceptible to heart disease compared to this strain, and we have a pretty good idea what we haven't even talked about that yet, what networks, gene networks, because we're not only talking about genes, we're talking about networks here, are involved. And now if I put those animals under environmental conditions that disrupt the circadian clock, whether it's a time of day of feeding or we phase shift the light-dark cycle, how are these models of cardiovascular disease or diabetes, how are they responding to that? So I think there's a lot of power in the genetic animal models that has not been exploited.
So do you think that can be exploited to some degree as well to identify biomarkers of disruption?
Like I was saying earlier, I think that we need to get a wide range of biomarkers and get an understanding of the timestamp of those, and then determine that when we phase shift the biological clock of one strain of mice that's genetically different than this strain, that we find that there are 20 biomarker rhythms which are moving fast and 30 that are moving slowly, and they're more susceptible to the adverse effects. I think combining those will be a very powerful approach.
So what would facilitate that right now?
Money.
No.
Hey, we got to agree on that one.
Of course there's money, but what would the money be used for? I mean, could you, hang on.
I'll do the right thing.
I was just thinking that one of the things that the extramural program at NIEHS has recently done has been to pull together a kind of place for a database for a lot of information that relates to childhood exposures, for instance. I mean, is that something that would facilitate this? Is that something that's kind of crazy? And how does the work get a little bit standardized so that we're talking apples and apples rather than apples and cheese?
Yeah, that's a tough one. They've got, for example, there's databases on what's called the Phenome Project, where they're looking at all these strains of mice and somebody's looking at open field behavior, somebody else is looking at body weight gain in response to a high-fat diet, and then they try to put all that into a general database. Plus, we already know, if we've got 40 strains of mice that we've sequenced, and we find that these 5 strains of mice are particularly responsive to highly sensitive to some circadian disruption, and these 5 are not, we can go into these 5 strains and say, what are their common areas of the genes that they have, the genomes, what common areas of the genomes, which one are these, and then pull it up.
Yeah.
And I don't,
That
we go into that
comparative
base
work.
every now and then, and the problem with what we'd like to say is that, and this gets back to something we were talking about earlier, some diagnosis, or I can't remember who got, but the genome is easy, gene expression easy. The difficulty is the phenotype. If you go into a population of if you get 100,000 depressed people and then you do a GWAS study on them, and if you don't come up with anything, it's because your population has such a diverse phenotype. It's not depression. There's 20 different depressions in there, and you got to pull them out. So it's also been hard to annotate the phenotype data and what were your laboratory conditions. There was a paper in Science this week which said that mice studies were discovering that depending upon the laboratory conditions, I mean, you're talking about not preventing the light from leaking into a dark room or something, and it was unbelievable. It said Chris Caldwell has discovered that he does his studies he reverses the light-dark cycle, so he does his studies in the dark. Everybody else does them in the light because they're doing them when they're normal work hours. And he's getting totally different results. Well, he gagged me with a spoon. Of course he's getting different results. And so going into this kind of phenotype data, we don't know. There's not enough information quite there. So.
Okay. So that's not something that's a short term, potentially. Yes?
No, I think in terms of phenotype, from today's discussion, we know that light at night can cause at least lifestyle disturbance in terms of, say, reduced physical activity or tobacco use, and then disturbed sleep, disturbed eating pattern. So in terms of phenotyping the effect of extended light, these are some of the factors that we must be collecting with timestamps so that we can identify misclassification or confounding factors. And then second is some of the adverse effect of extended light or insufficient light might be mediated through some of these factors. And the question is, if we control for, say, physical activity or increased sleep or reduce or control for eating pattern, can we reverse or attenuate some of the adverse effect of extended light? So these are just comments.
When you say short term, what do you mean? What do you mean by short term?
Probably a year. 2.
What are some things that you might be able to get answers to in a year? Depends on the amount of money, right? Yeah, no, it's true. Yeah, but I think that one of the points that you just made is that maybe one of the biomarkers of disruption should actually be feeding pattern, or which I don't know if that applies. I mean, that applies to animal models. That applies to humans. Is that something that should be potentially worked up to a greater degree? Yep.
Well, I think that's an interesting point, but that can change. The feeding pattern can change even on the basis of the intensity of light at night that you expose the animals to. For example, we kind of stumbled on this when we did our animal model. When we did the dose response curve. What do you call it? 4-parameter fluence response curve for our animals that were implanted with breast cancer. We found that there was a light intensity in that dose response at 0.2 lux that gave almost the same effect in terms of stimulating tumor growth and metabolism as bright light at 300 lux or whatever it was, where we've saturated out the suppression of melatonin. But in that 0.2 lux intensity, when we monitored the fatty acid levels in the blood, which reflect the feeding behavior, the circadian feeding behavior, and we use this as one way of monitoring that, there was absolutely no change. So that indicated to us that at least that aspect of quotes, I don't know if it's correct to say this, but general kind of circadian function was preserved in that animal at that light intensity. And if someone just looked at that parameter of feeding, they'd say, oh, these animals aren't circadian disrupted. But then you look at melatonin, and they're disrupted. So I think that's an important point. Feeding behavior could be maybe a marker, but we have to realize the subtleties of how light affects different parts of the circadian system.
So actually, that was a little bit of what I was trying to get at when I was kind of asking about, is there a way that we can pull together the information that we have? Really, I think in a way related to the fact that, we've all been talking about the fact that there isn't just one circadian rhythm, but there are many circadian rhythms that are, as you're saying, differentially disrupted in different conditions. And there's a lot of information out there that different people know, but not everybody knows, and where it might be useful, in fact, for there to be a way that it be possible to be able to communicate this more broadly. It was just a thought. I mean, I wasn't trying to suggest that, but I was really kind of responding to what we've been talking about in terms of the variability and sometimes the integration, but sometimes the lack of integration of certain kind of rhythms. And is there a way that we can try to get our head around that?
Can I have a question?
Yeah.
Can I have a
Yes, thank
suggestion?
you.
Yeah. I think, first of all, to think there's just going to be one measure we make which is going to do it, I think is not real. What I think it is actually it's going to be like a combination of metrics. It's going to be something like suppressed melatonin, whether it's a nocturnal melatonin suppression that's been linked down to risk of breast cancer and hypertension, number of things at one end, which are diseases of rodents. It's going to be things like CRP. It's going to be a number of metrics, okay, methylation metrics. It seems to me if you really want a very focused program, so this is essential, by the way, this is essential for both the growth of the science and for policy setting. If you really want to do it, you want to do animal studies, you want to do short-term human studies, and I think by the way, you need light-type human study rooms, just like you have animal rooms, right? And you need to have people in multiple things. We've set up one recently to be able to run people and literally simulate shift work, so people come in and work weeks because you actually look what happens. And then you've got to have field studies where you're actually measuring it. If you got that coordinated and you went out and say, let's validate here's a putative set of biomarkers, and you looked at each of those animal models, short-term human in a controlled environment, and then out in the field, and you went out to those ones, I think you could do quite a focused program to actually narrow down at least a putative set for further validation of what those biomarkers might be. I think we've got pretty good guesses here. We need it, I think we all need it, to know what that is, because it A, helps drive policy, B, it helps drive interventions and the evaluation of effective interventions. That is key, because obviously part of this is also, and it also drives policy of what you do with individuals in evaluation. So I would say put a focus group in those multiple things together and have a group, a group plan to drive out those biomarkers. And by the way, just while we're saying it, we do have, as I say, a fully established facility that runs 24/7, has both sleep rooms and everything else, has work rooms. We're happy to have those facilities used by others, just so you know, that they are light tight and they have the various characteristics to be able to do that.
I guess one question I have about that, though, is I think it was yesterday it came up that it's not really mimicking natural light conditions for animals to be in completely dark rooms. And that's, so, are we then using this to more human studies to then mimic this artificial animal condition? Because we really care about the natural light conditions.
What I heard was we've got to have absolute control over light conditions, which means you've got to have the capacity to dark, but you're not studying in dark. You've got to actually have a baseline that makes sense. But at least, if you have light tight, you can now have total control of light exposure 24/7. But you wouldn't actually do much in pure darkness because that's not much use.
I think in terms of field study, we kind of have a pretty good idea about epidemiology of sleep, epidemiology of shift work and light, but we actually don't have clear data on eating pattern epidemiology and how variable is eating pattern among people and who are at risk of a circadian desynchronized eating pattern or long eating pattern. So I think very simple tools like what we are doing now with a smartphone app. We have an app called My Circadian Clock that works both on Android and iPhone. It's for academic research now. And that's why we can actually integrate, we can collect simultaneously, say, eating pattern, sleep, self-reported sleep, and any sensor that's connected to Apple Health Kit or Google Fit. So these kind of tools will actually help us to get the extent of circadian disruption with respect to sleep, eating pattern, and build some model.
So I guess we had some discussion earlier about the importance of validating the exposure information and trying to translate that into something that could be used in a field study relating to, questionnaires rather than having to measure everything. But I would assume that similar work has not yet been done to establish the eating pattern questionnaires, or have they already been included in the studies from Dr. Hansen and Vermeulen, for instance?
We have some basic questions. The interesting thing is, of course, where are you interested in the eating pattern when people do shift work, or actually what their normal eating pattern is when they don't do. And so it becomes actually quite a bit of a questions, and that's what we have limited information now. But actually, implementing apps is something that can be done, and we're doing for other purposes, and so that would actually be a nice way forward to actually collect objective information from the study population.
Thank you.
Back to short-term projects. So one of the more interesting papers that was included in the summary was this review by Operwiesen, I think it was. This it was a it wasn't a meta-analysis, although I think they called it that. It was a compilation of 4 different categories of effects in rodents, timing of feeding, light manipulations, and so on. And they looked just at rats and mice. And one of the things that was striking was how inconsistent the results were. And I think there was plenty of positive results to believe that there were real effects, but it was striking that what was true of the rat was not true of the mouse, and what was true of the rat in one person's hand was not true of the rat in another person's hands with slightly different conditions. Other fields have worked, I think, really hard to standardize protocols. In the alcohol field, I think for animals, they've done exhaustive studies with exactly the same protocol with different strains of mice and looked at heritability and all sorts of things. And I think something like that is lacking in our field and might be an important project just to have one lab, I don't know, NIEHS or something, do it with the quantification of the light. I mean, who knew that the blue tinted cage is going to, make this huge difference? But to do it all in one place with rats and mice and identical exposures, maybe even throw in an animal model, a diurnal animal model that's got some genetic variation in it, to start working that way. I think that might give us a more firm foundation in terms of identifying these biomarkers and using them if we had sort of a better grasp on all of that.
Okay, thank you. I think you've got a lot of agreement around the table. So just to respond a little bit to this idea of is there a way in which we can begin to look at biomarkers across the different types of studies? I guess one of the questions that I would like to pose is whether we're there yet. And, I think that we may well be there in a number of different things, but are there any gaps that would be important to fill to get there? Yeah.
I don't think I talked about this yesterday, but one of the things, if you wanted to get data really fast, let me just tell you, we did a study with a drug company, maybe I won't mention the name, with a cloud-based company. They wanted to know how do people with 20 different conditions, ranging from diabetes to arthritis to asthma, how do they sleep? And we sent out a 96-question questionnaire July 1, and by July 15th, we had 5,000 responses. And I can deal with Parkinson's disease because we've published one paper and we're publishing more, in which we were able to show that people with Parkinson's disease have these sleep-wake characteristics. You can even relate it back to what drugs they are taking. And so I think if you want to collect data, and you have to pose what do you want? You want to know if there's a relationship of cancer and shift work. You want to know if there's a relationship of cancer in people who have had a lifetime of social jet lag. You could get that information from me. We'd have to, we could do literally within 15 days. It takes us usually about 6 months to design the study and to make sure the questionnaire is right. And you may beta test it too on 100 people or something before you go out to 10,000.
If I may suggest, when you beta test on the 100 people, what we're doing with American Cancer Society, where you do a more extensive sort of validation of these, and then you send out to all the 5,000 people, 10,000 people, or a number of people. That probably it's a sort of a good way to do it.
Yeah, and I think we're not using those kinds of capabilities. I mean, the instrumentation is coming, but in terms of gathering data, I can just to give you another example. there were a few papers that got published, like there's been a few papers linking, prostate cancer with this. And the question was, does lithium good for Lou Gehrig's disease? And they set up a clinical trial at NIH, spent about $50 million on the clinical trial, and concluded no. And Jamie Haywood had already determined that by getting 10,000 people and finding out how many, and 1,000 of them were taking lithium, and 2,000 were not, whatever the number is, and he demonstrated that there was no change in the progression of the symptoms in lithium, and he did that for about $500,000 instead of $50 million. So that kind of capability is out there. If you really want to get data on cancer or non-cancer, I think you're particularly interested in cancer, and different sleep-wake characteristics, whether we're or circadian. Sorry, I mentioned sleep-wake. Different circadian characteristics, circadian phenotypes, and you could put feeding is in there too. I mean, you can say, what time of day are you eating, and how does that change
you could
on the
take
weekend?
a picture of it with your smartphone, right?
Oh, that's right.
So I gotta ask, was that latter study a case control study?
What do you mean by case control?
Oh, they had Parkinson's, non-Parkinson's, checked the lithium, observational.
Oh, first off, the lithium one was...
You said there was a $20 million project that found no effect. That was an intervention trial?
Well, that was the NIH clinical trial. And yeah, they were giving some people, right, they were giving lithium,
Randomized
this
control
group,
trial.
randomization, and determined after 2 years, hey, there's no difference in progression.
But somebody did a $500,000 study before that knew it already.
Well, it would say they did it before. That study was ongoing when he did that. And then published his paper.
It was not a randomized controlled trial.
No,
Okay.
no, not at all.
Observational epidemiology.
Not at all. In fact, that's a very good point. That you're going out there and you're getting 1,000 people with Parkinson's who are taking this drug, and 1,000 people with I'm using Parkinson's because I know a little bit more about it than Lou Gehrig's disease. 1,000 people without it, and then you're coming back and saying, hey, look it. There's no difference in response to this drug, or this drug is slowing down the symptoms.
Are we getting into the difference between observational and randomized controlled trials?
Plug observational epidemiology and transact yet.
So I would love not to believe the Women's Health Initiative trial. Yeah. So I think we're kind of pulling things together. And I know we have a little bit more time, but I just am feeling like maybe we're close to where we wanted to be by now. And I just wanted to really give, first of all, the panel around the table, and then, people in the audience, a final opportunity to make comments on, again, kind of short-term potential research directions, or even statements, or consensus-type statements that would help move the field forward, so that not everybody had to do the same thing.
Right, and it doesn't just have to be a short-term study or something we can do at NTP, because we are trying to work with extramural on this. So just any big research gaps or things that can move the field forward.
Yeah.
Just woke up again. What would be very helpful, I think, for the shift work observational studies that we do, when we point this very complex picture of what aspects could all be related, and I think what would be very helpful is to have experiments that actually would isolate some of those to really get a better handle of what is driving which effect, and in turn that actually can inform how we actually analyze the epidemiological data, or what questions we should really be asking or not. And so I think that is something that I just wanted to basically put out there, that it's something that would be very helpful, at least for the shift work community.
Don't use armadillos, they carry leprosy.
I have a
Point
basic,
taken.
I have just a basic question, and that is, who are we trying to help? And will it be very inclusive? Because when we talk about light at night issues, for example, a friend of mine, just as an example, is totally blind, and he came to visit me a couple days ago in a beautiful blue sky sunshine day with his seeing eye dog. And he was wearing dark glasses. And I said, why are you wearing dark glasses? Hasn't your doctor talked to you about circadian disruption and that you need that blue light at night so you can produce more melatonin? You need that blue light during the day, especially in the morning, 10 o'clock, and so you can produce more levels of melatonin. And we went into this. He's very interested, and I'll bet that he's one of the persons listening on this webcast, because no one ever talked to him about that. So like, as it was mentioned quite a few times, shift workers, there's shift work, but that really affects the whole population.
Thank you, and I think that in some ways, really takes you to a somewhat different advocacy group, which is not I'm not saying that this isn't a good idea, but I think it also, again, there are different kinds of blindness, and that's actually an important kind of thing that could potentially come out through, support groups. Well, thank you, everybody, for this has been, for me, very exciting. I've been thrilled to be at the table, and I really appreciate everybody's thoughts on, trying to pull some of these things together in terms of thinking of where we really need to be going and where it would be helpful to have information that would just help everybody. So thank you.
So I'd like to thank everybody. We've really learned a lot. We appreciate all your time, expertise. And I just wanted to talk a little bit about next steps. I mean, we kind of mentioned them at the beginning, but we hope to distill all this information, and we hope to be able to prepare a report and that we can circulate out. And maybe our target's about a couple months for that. And then the other step that I talked about was that OHAD is going to prepare a concept that they hope to present to the board of our NTP Board of Scientific Counselors, and that'll be in December, and we'll probably be in touch with you shortly. Thank you so much, and I know.
Thank you, and safe travels.
Thank you.